You ever stop and think about what's actually happening inside a chatbot or one of those translation apps? I mean, it feels like straight up magic, right? But behind the scenes, there's this special kind of artificial brain, one that's built specifically for language. And today, we're going to pull back the curtain and explain why that tech is the way it is.
So let's start with a question that sounds simple, but is actually mind-blowingly complex. When you or I read a sentence, our brains are doing a million things at once. We're not just seeing words, we're processing their order, their relationships, the whole context. So how in the world do you teach a machine to do that?
Because really, that's the heart of the problem, isn't it? Think about it. The dog chased the cat. Got it. Now, the cat chased the dog. Whoa, completely different story. The words are exactly the same, but the sequence, the order, changes absolutely everything. And that sequential nature of language, that's the first huge hurdle for any AI. To even begin to solve this puzzle, a whole field of AI had to be born. It's called natural language processing, or you'll usually just hear it called NLP. And its entire job is to build a bridge between our messy, human language and a computer's world of ones and zeros.
You see, the point of NLP isn't just for a computer to recognize a word. The real goal here is so much bigger. It's for computers to actually understand, to interpret, and, get this, even generate language in a way that feels natural to us. It's all about creating a real conversation.
Okay, so if sequence is the name of the game, we can't just grab any old AI model off the shelf. We need a specialist. We need an architecture that's designed from the ground up to think in a line, just like we do when we're reading a book.
And that specialist, that's the recurrent neural network, or RNN. This is a really powerful type of neural network that turned out to be the perfect tool for these kinds of language-based jobs.
This quote right here really nails it. That fancy phrase, temporal dependencies, all that really means is that the network understands that what was said a second ago has a huge impact on what's being said right now. And that, my friends, is the secret sauce for understanding language.
So here's a simple way to picture it. An RNN doesn't just gulp down a whole paragraph in one go. Nope. It reads one word at a time. And as it moves to the next word, it carries this little memory of the words it just saw. That memory is what provides the context, letting it piece together the meaning of the sentence as it goes along.
So what does one of these systems actually look like under the hood? Let's peel back the layers a bit and see the basic framework that's powering so many of the language tools you and I use every single day.
All right, it pretty much breaks down into 4 key stages. First up, the input layer, just takes in the raw text. Then you've got the embedding layer. This part is cool. It turns those words into numbers, into vectors, that actually capture their meaning. It's like building a map where words with similar meanings are neighbors. Then comes the star of the show, the recurrent layer. This is the RNN itself, processing those numbers in order, building up that all-important memory and context. And finally, the output layer gives us what we came for, the translation, the summary, or the answer to our question.
Okay, this is a great question. You're probably thinking, hold on a second. I hear all about these amazing AIs that can spot a cat in a photo from a mile away. Why not just use one of those for text? Those are usually convolutional neural networks, or CNNs. So why not?
Well, the answer comes down to the most important rule in this whole game. You gotta use the right tool for the job. And when we're talking about AI, that means you have to understand the huge difference between looking at a picture and reading a sentence.
And this lays it out perfectly. A CNN is a master of spatial data. It looks at an image and sees all the patterns, the edges, the shapes, the colors, all at once. The position of a pixel matters, but not its order and time. An RNN, on the other hand, is a master of sequential data. For an RNN, the order is absolutely everything. It's built from the ground up to process things one step at a time, holding on to that memory of what just happened.
So here's the bottom line. The simplest way to put it, CNNs are for seeing, RNNs are for reading. They're 2 totally different, highly specialized tools built for completely different kinds of problems.
And believe me, this is not just some abstract theory. This technology is everywhere. That virtual assistant on your phone that gets what you're asking, that's this. The tool that can summarize a massive article for you, that's this too. Even the systems that analyze product reviews to see if people are happy or mad, it all comes back to this fundamental ability to understand language as a sequence.
So in the end, it really is that simple. You gotta pick the right tool for the job. And for the unique, flowing, sequential puzzle that is human language, the RNN is the specialist you call in. Now, of course, things have gotten even more advanced since then, but this core idea of processing language in order is still the foundation of the entire field.
And that leaves us with a really fascinating thought to chew on. We've built machines that can follow the sequence of our words, but what about all the stuff that's between the words? You know, subtext, sarcasm, real creativity. As AI gets better and better at the sequence, what do you think is the next great barrier for true understanding?